Here we're looking at how to solve linear inequalities. We talked about this yesterday, but now we're going to see a little bit more of a process with it. I'm going to skip these first couple of examples here. These are exactly like what we did yesterday. Some of these are similar to it. It'd be good to review just a hair bit. So remember, we're solving these similar to an equation, except for there's the one special rule that as we solve these inequalities, if we have to undo anything by multiplying or dividing by a negative number, you have to switch the direction of the inequality sign. So here, negative x is less than or equal to 8. Well, I want to know what x is. So x is being multiplied by a negative 1 here. So I divide by a negative. When I divide by a negative, after I simplify the left and the right side, 8 divided by negative 1 is negative 8. Now, instead of bringing the inequality symbol down as it is, I have to switch the direction of it. So Pac-Man was eating to the right. Now Pac-Man eats to the left. In case you see a fraction, remember to undo multiplying by a fraction multiplied by the reciprocal. By the way, this is a negative fraction, and a negative times a negative will give me what a positive x is. So I'm going to multiply by a negative. Now I want the reciprocal, so the 5 goes on top and the 2 goes on the bottom. And that negative sign, this is a negative fraction and this is a negative fraction. So don't worry about the fact that the 2 is negative on this one and now it looks like the 2 is positive on that one. Negative fraction, negative fraction. What we do to one side I have to do to the other. So now I'm multiplying the other side of the inequality by a negative 5/2. So the bells, lights, whistle should go off. I'm multiplying by a negative with these inequalities, so I need to flip the direction of the symbol. So these multiply to just 1, so I get x on the right side. 4 times negative 5 is negative 20. Negative 20 divided by 2 is negative 10. Now bring down the inequality, but switch the direction. Pac-Man was eating to the left, so now Pac-Man eats to the right. Bada bing, bada boom. So that was a review of what we were doing yesterday, solving inequalities. Now you'll get some two-step inequalities, like example number 1 down below. And then I'm going to push you a little bit. Now remember, here's our solving process. You know, we used to just talk about what was being done to what side is the variable on, what's being done to it, and how do you undo it, and then check your answer. So let's try that for example number 1. X is on the left. Now what's being done to it? It's being subtracted by 6 and multiplied by 2. Remember, we have to undo subtraction and addition first. So I have to undo subtracting 6 by adding 6. So we get 2x is less than or equal to 18. Now x is being multiplied by 2, so we need to divide by 2. We're dividing by a positive 2 here, folks. We're not going to flip the direction of the inequality. So we get x on one side of the inequality and 9 on the other side of the inequality. And again, we're not flipping the direction. So we keep Pac-Man eating to the right. There is our solution. So example number 2, what side is the variable on? In number 2, it's on the left. Now, so if there's more than one, we'd have to either combine or get the variable to one side of the inequality. So that doesn't apply here because there's only one variable. Are there parentheses? Yes. Can you distribute? Yes. Now careful here, what are we distributing through? It's a 3. Is that 3 positive or negative? It's totally negative. We need to add the opposite right here. That's a negative 3. So when we distribute, we get negative 3x plus negative 6, or minus 6. So we have 1 plus negative 3x plus negative 6 is greater than 28. Now, can we combine any like terms? Yeah, you could combine on one side of the inequality, we have a negative 6 and a positive 1. So that's really the same as negative 5. So we have negative 3x plus negative 5 is greater than 28. And so now from here we'll add 5, you get negative 3x is greater than 33. And then we divide by negative 3. Oh, we're dividing by a negative, so we get x on the left side and negative 11 on the right side. That inequality needs to flip directions. See how it was, we kept on moving it down this entire time because we never multiplied or divided by a negative, so the Pac-Man faces the same direction, but now we divide by a negative, so Pac-Man needs to eat to the right. Whoa, there's our answer. Boom. Example number 3. Which side is x on? It's on the left and the right. If the variables are on the same side, combine like terms, so they're not on the same side. If the variables are on both sides of the equation, undo the smaller coefficient side. So this is a 3x and this is a 5x. 3 is less. 3 is smaller. I'm going to undo that by taking it away. 3x minus 3x is nothing. Good. Now I don't know if x is on the left side. Of course, to keep this thing equal and balanced, what I do on one side of the inequality, I have to do on the other. So now on the right side, we actually only have 2 x's. So now, what side of the equation is the x on or the variable on? It's on the right. Undo the things that are being done to it. So we'll add 4. We get 6 is less than 2x. Now divide by 2. So the answer is 3 is less than x. Or x is greater than 3. Let's rewrite that with x on the left, starting with x. So x and 3 switch sides around this inequality. But again, the answer is x is greater than 3. So our Pac-Man also needs to flip directions. So that's the one other time that we flip the Pac-Man. When we switch the sides of the x and the number, we have to switch the direction the Pac-Man's facing to keep it saying the correct answer, or meaning the correct thing. There we are. Let's stop there with